I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the participants for joining our teams for Olympiad and Gauss Math. In the series, we are discussing many types of questions which could be important when it comes to competition and for better concepts about the topics learned at school. In case you want to join my classes, you can always send an email on the address given. Now here we are discussing 3 questions. These are communication and thinking based questions. I made them multiple choice since in many competitions you see multiple choice questions. Now the question here is, for what value of n will the equation 9 plus 6x equals to 3 times nx plus 6 have no solution? You don't have to find the solution. You have to find the value of n for which there is no solution. You get the idea. Next question is similar. Says, for what value of n will the equation 2,4 plus 6x plus 3 times x plus n have infinite solution? Now it is important to understand that when we are talking about equations on both sides of equality, we are actually talking about 2 different equations. Now they could intersect at one point, at no point, and at infinite points. And based on that, we have this particular question. Great. Question 43 is, for what value of n will the equation 2x plus 1 minus 1 times equals to half times nx plus 1 have no solution? You get the idea. So n could have any of these values shown in the multiple choices, and you'll figure out that one of them will satisfy the condition. How do we solve such questions in minimum time is what we need to understand. Also the concept behind the type of question we are looking at, right? Okay, so let's begin with the solution of the very first question, which is, for what value of n will the equation 9 plus 6x equals to 3 times nx plus 6 have no solution, right? So when we are saying equations have no solution, it really means that the lines are parallel. You get the idea. So parallel lines do not intersect. Parallel lines do not intersect, and therefore there is no solution. Right? So that is the case for no solution. Now what is the condition that they will be parallel and therefore there is no solution, right? So that is what you need to figure out. So clearly the slope m is equal, right? So we say if there are 2 lines, m1 is equal to m2, but their y-intercepts are not equal. So b1 is not equal to b2. Now when I say m1 and b1, what do I mean? Normally we'll write equations in the form y equals to mx plus b, where m is the slope and b is the y-intercept. You get the idea. So what I'm saying here is that if, let us say, we have this on a coordinate plane, then b1 and b2 are these values. You see that? And slope is a gradient, right? Okay, so I hope the concept is clear. Now let's look into the equations. So one equation is 9 plus 6x, right? And the other one, which we have equated to, is 3 times nx plus 6. So let us expand the right hand side and see what do we get. So when you expand, you get 3nx plus 12. And on the left hand side, we have 9 plus 6x. Now 9 plus 6x has a slope of 6 and the other has a slope of 3nx, right? So these are the slopes, right? This we can say is slope of the first line, and that is the slope of the second line. And these should be equal to find the value of n. So we'll equate that. So we can say 6x equals to 3 times nx, and now dividing by n, we need to isolate n. So dividing by 3 on both sides, right? So we can now divide by the number 3, right? And also x we can divide by, correct? So when I do that, I can clearly get the value of n. And so what I get here is the value of n as 6 divided by 3 as 2. You get the idea. So that way, by comparison, we are solving. So the answer is n equals to 2, which is option B. Is this concept clear to you? We did not really solve for anything. We equated same slope and the y-intercepts are different. One is 9, the other one is 12. So they were different. So we don't have to think about it. Perfect. So I hope this is absolutely clear. Well, in case you want to learn from me, you can always send an email on the address given. So now let's move on and take the solution of the next question, which is, for what value of n will this equation equals to that have infinite solution? So infinite solution means what? It means that if that is my one of the lines, right, then the other line is exactly over it, right? So then only you get infinite solutions, right? So the other line is over it, right? You get the idea. So they are intersecting at each and every point. So in that case, m1 should be equal to m2. They are definitely parallel. But the y-intercept should also be equal. But then only they are exactly same lines, right? So keeping that in mind, let's write down the equations and work on it. So we have 24 plus 6x as one of our lines. Treat them as one line and the other line. Then be easy for you to understand the concept. So right hand side, apply the distributive property, expand. So we have 3x plus 3n this time here. And here we have 24 plus 6x. Now we want the same slope, correct? We want that m1 should be equal to m2. So these are the slopes, right? These are the slopes which we want exactly same. But you see they are not same. It is 6 and 3. But can you do something about it? Well, we can divide the left hand side by 2, right? So I can factor out 2, for example. I could rewrite this as 12 plus 3x. Now, does it make sense? Now let's compare, right? So 3x plus 3n. Does that make sense now? I could have factored 6 also, right? Well, it makes sense. Now we see that if I see this 3x and 3x, they have the parallel slope, correct? And we can now compare the y-intercepts. So now we have same slopes, right? We have seen that slope m1 is equal to m2. We can say m1 is equal to m2. And if I do that, well, 3 is the slope, right? So we say 3 is the slope. Well, I could have also taken 3 common, correct? I could have taken 3 common. Slope will be 6. You get the idea. So let me do it that way. So I will take 3 more common. So that is to say, I could have taken 6 common here, right? As many of you thought about, correct? So we get 4 plus x here, and the other one, I could have taken 3 common. And so I get x plus n. Does that make sense? So this is better. You see that? So what you do is, you factor out those additional terms, right? The line is same. Line is not changing. Because we're thinking about this line equal to 0, right? Now you can compare that the slopes are same and they are basically equal to 1, right? And if that is the case, then these are the y-intercepts which should be equal. So we say n should be equal to 4 for exactly same lines. You understand, right? So when we factor out, we are writing equivalent equations, right? So note here the concept of equivalent equations. Now that helps, correct? So if you have some doubts, you can always email me on this particular address and we can explore more. How do we understand these situations? Make sense, right? So that's another example. It is a learning experience when you join my classes, and that is why my students are doing so well. Now let's move on and take up the next example, which is question number 43. For what value of n will this equation equal to that have no solution at all? So once again, no solution. I think now you understand the concept. Really speaking, the lines should be parallel, right? So parallel lines will have no solution, and that means we are looking for the situation where m1 is equal to m2, but their y-intercepts are different, right? So their y-intercepts are different. So this is similar to what we did. I'd like you to pause the video, answer this particular question, right? Okay, great. So I'll help you approach the problem by saying that there are two different equations of line. One is 2x minus 1, and we want to make them equal. Means when we consider a system of equation, we see that both when graphed will never intersect, right? This is what we are looking for, right? So half, and we have here nx plus 1, correct. Now, for these equations to have no solution, they should have same slope, right? And different y-intercept. So if I open this up, I get what? I get half n plus half, right? Clearly, the y-intercepts are different, right? So b1 is not equal to b2. Since b1 is minus 1 and b2 is half, right? There's x here, right? Okay, so b1 is not equal to b2, so definitely we are looking for now same slope. So let me make m1 equal to m2. So that is to say the slope m1 is 2, and here it is half n, right? So 2 equals to half n. Makes sense, right? So cross multiply, we get 4 equals to n as the solution, and therefore D is the right answer. Does make sense to you? Perfect. So in these examples, you see, we learned quite a few things. One, we applied the distributive property in many of our examples and rearranged the terms. We also looked into equivalent expressions, and that is why it's a communication and thinking question. You have to explain why you got this particular answer for this question, right? So I've combined both the things, which is you have test papers in some competitions which are multiple choice questions, which are kind of here, but sometimes it is a communication and thinking question. So there you have to explain your answers. I hope with this example you have understood the complete strategy for solving such questions. Normally, these are not discussed in the books, and therefore I will encourage you to join my classes and look into some beautiful videos which we have shared for you. Feel free to write a comment, share your views. In case you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.